Hello friends, today we are going to understand a concept of IPv4 header. So as you can see, IPv4 header is actually used for encapsulation purpose when the segment comes from the transport layer and network layer needs to attach its own header. So the header which is attached for an IP packet is this IPv4 header. So what you can see with IPv4 header is the first field. Actually, the entire IPv4 header is of 20 bytes. So if you see every row, there are total 5 compulsory rows. Every row, if you see, is of 4 bytes. So total 5 rows which goes up till 20 bytes header. Minimum 20 bytes without option. If there is an option, the header may vary between 20 to 60 bytes. Maximum data it can carry, including header, is 65536 bytes. So the first part of the header is a 4 bits field known as VER. VER stands for version. There are only 2 versions of IP, that is either version 4 or version 6. If it is version 4, the value here is 4. HLen. HLen is not actually a header len. It is a value which will help you to calculate header len. So whatever a value is there present in HLen should be multiplied by 4, which will give you a header length. So if the value there is 5, so 5 into 4, so the header length is of 20 bytes. If the value there is 6, so it is 6 into 4, which is 24, out of which 20 bytes would be a header and 4 bytes would be a option. After that you can see DS. DS stands for differentiated services. So if you require any special type of service, it would be specified over here. Specifically, we focus on 4 types of service, that is minimum delay, minimum cost, maximum throughput and a maximum reliability. Then we have a total length. Total length, as you can see, is of 16 bits. So maximum value which can be there at total length is 2 raised to 16, which is 65536, and hence the maximum size this header and a packet can carry is 65536 bytes. Next is identification. Every unique packet is given, or every new packet is given a unique identification number. Actually, this identification number is helpful for fragmentation. So when you fragment the packet into multiple sub-fragments, which is known as fragmentation, then every fragment of the same packet will have a same identification number, which is helpful for reassembly. Then you can see 3 bits flag. 1 is don't care and 2 are do not fragment and more fragment. If do not fragment is 1, you cannot fragment the packet, and whenever there are more fragments, so first and the middle fragment will have MF set to 1, last fragment will have MF set to 0, and a fragmentation offset tells the relative position of the fragment in the packet. So again, it is helpful for a reassembly purpose. The next thing what you can see is a TTL, which stands for a time to leave. It tells how many router a packet can visit. So it is avoiding unnecessary wandering of the packet in the network. So if TTL is 5, it will go to the router. Router will check the TTL value. If it is non-zero, it will decrement TTL by 1. So now TTL will become 4 and packet is forwarded to the next hop. If TTL is 0, the router is going to discard the packet. Then what you can see is protocol. So which protocol is actually responsible to handle this packet? The value of that protocol is written. Header checksum. Header checksum is actually a error detection mechanism. So checksum is calculated at the sending side, then it is also calculated at the receiving side. In case of any error, if found, the packet is discarded. And then 2 things what you can see is source IP address and a destination IP address. And finally, some set of options if required. So this is a small explanation about IPv4 header. Thank you.